This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at rational equations. Let's take a look at our first problem here. This one won't really demonstrate all the steps, but m plus 48 over m is equal to 14. And this is solving rational equations. Step 1. Factor all the denominators. Well, here we just got a single m, so there's nothing to factor. Step 2, figure out the LCM of all the denominators and multiply everything by it. Okay. Well, we look at each factor, look at the m, and we're looking for the greatest number of single m's in any denominator. Well, the greatest number, there's 1 here, so the greatest number of m's in any single denominator is 1. So we're going to multiply everything by m. Now, when I say everything, I'm talking about what's separated by pluses and minuses and equals. So we're going to multiply the m by m, the 48 over m by m, and the 14 by m. Now this m cancels with this m. M times m is m squared plus 48 equals 14m. And 3 says solve. And usually I put solve for x, but we'll just say solve. And that's pretty vague. That's what we're doing initially. We're solving. But every problem will be different. This one has an m squared, so it has a quadratic. So when you have a quadratic, you want to get everything over one side, 0 on the other, and see if you can factor it. So I take the 14m over, and we get m squared minus 14m plus 48 equals 0. Now to factor this, we're going to use the PSD, because we got m squared, m, no m, and there's no number in front of the m squared. With PSD, we take the number at the end, the 48, and we ignore signs. So if there's a negative 48, we still just take 48. And we come up with our 3 columns, our P column, S column, and D column. P, we list all the product, give us 48. We got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. In the S column, we add these together. 1 plus 48 is 49, 2 plus 24 is 26, 3 plus 16 is 19, 4 plus 12 is 16, 6 plus 8 is 14. Difference column, we subtract smaller from larger. 48 minus 1 is 47, 24 minus 2 is 22, 16 minus 3 is 13, 12 minus 4 is 8, and 8 minus 6 is 2. The number we're looking for is a number on a middle term, which is 14, which is right here, so we're going to use 6 and 8. Now our larger number in the P column that we're using, which is the 8, will always be the same sign as the middle term, which is negative. The number I circled in the S column, S for same signs, so if the 8 is negative, the 6 is negative. Now zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set m minus 6 equal to 0 and m minus 8 equal to 0. And we solve those and we get m is equal to 6 and m is equal to 8. Now step 4. Semi-check your answer. So semi-check your answers. Now what I mean by that is you don't need to fully check it, but you want to make sure that when you plug those values back in, they don't cause the denominator to equal 0. For example, if I put 6 in for the m, put 6 here, put 6 here, 48 over 6, well, that doesn't cause a 0 in the denominator, so that's our answer. If we put 8 in here, 48 over 8, well, our denominator is still not 0, so both of those actually work. Let's take a look at our next problem. 5 minus x over x minus 5 plus 5 equals 8 over x. This one's actually got a shortcut that I'm going to ignore. Notice how this is 5 minus x and this is x minus 5. Well, if I were to factor out a negative 1 up on top, what I'd find is that all of this fraction here gives us negative 1. So we'd have negative 1 plus 5, which gives us 4. I'd like steps to work 100% of the time or as close as possible, though, so I'm going to ignore shortcuts. Okay, first step. Factor all your denominators. Well, we got x minus 5 and x. There's nothing to factor. Step 2, figure out our LCM. Realize that this single x here is different than this x over here. So we'll start with our first factor. We'll start with x. And I'm looking for the greatest number of single x's in any single denominator. There's none here, there's 1 here, so we'll have 1x. I go to my next factor, the x minus 5. Now I'm looking for the greatest number of x minus 5's in any single denominator. There's 1 here, none here, so we'll use 1. The answer to that will almost always be 1 when I ask you how many of these do you have in any single denominator. So that's our LCM, and that's what we'll multiply everything by. And again, when I say everything, I'm talking about what's separated by pluses and minuses. Okay. Well, this x minus 5 here cancels with this x minus 5. This x here cancels with this x. And so we're left with, I'll write it down, then I'll multiply it through. We're left with x times 5 minus x plus 5x times x minus 5 equals 8 times x minus 5. Well, x times 5 is 5x. X times negative x is negative x squared. Plus 5x times x is 5x squared. 5x times negative 5 gives us negative 25x. Equals 8 times x is 8x. 8 times negative 5 is negative 40. Now we want to combine together like terms at any step. Here we have a negative x squared plus 5x squared. That gives us 4x squared. 5x minus 25x gives us negative 20x equals 8x minus 40. Now step 3 is we want to solve. In this case we want to solve for x. And we have a quadratic. We have an x squared, so we want to get everything over one side, 0 on the other. So I'll take the 8x minus 40 over. So we've got 4x squared minus 20x minus 8x plus 40 equal to 0. Which gives us 4x squared minus 28x plus 40 equal to 0. Well, the first thing I can do is I can factor out a GCF. They're all divisible by 4. So I bring a 4 out, and that leaves us x squared minus 7x plus 10 equals 0. Now what's inside the parentheses is going to be PSD. Because we have x squared x, no x, there's no number in front of the x squared. So I'll take the 10, come over here, and I'll create my 3 columns, my P column, my S column, and D column. In the P column we'll list all products, give us 10. We got 1 times 10, 2 times 5. In the S column we add those together. 1 plus 10 is 11, 2 plus 5 is 7. In the difference column we'll subtract them. 10 minus 1 is 9, 5 minus 2 is 3. Now the number we're looking for is a number in our middle term, which is a 7, which is right here, so we're going to use 2 and 5. The 4 carries down, it doesn't change anything, but we have to keep carrying it down. And we use 2 and 5. Now our larger number in the P column that we're using, which is 5, will always be the same sign as the middle term, which was negative. The number I circled in the S column, S for same sign, so if the 5 is negative, the 2 will be negative. Now the zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. Now, it never does us any good to set the number equal to 0. So if I set 4 equal to 0, there's no x to solve for, so that goes nowhere. So we'll set x minus 2 equals 0 and x minus 5 equal to 0. And we get x is equal to 2 and x is equal to 5. Well, step 4, semi-check your answers. If I take the 2, put it up in my original problem, 2 minus 5, that's not 0. If I put 2 here, it's not 0. So that one's fine. Now if I take the x equals 5 and plug it back up here, if I put 5 in for x, I get 5 minus 5 in the first fraction here, which gives us 0. So this one causes a 0 in the denominator. So we're going to cross that one out. So our only answer is x equals 2. Let's take a look at this one. We got 3 over x minus 7 plus 2 over x minus 4 equals 9x minus 2 over x squared minus 11x plus 28. Step 1. Factor all of our denominators. X minus 7 we can't do anything with, x minus 4 we can't do anything with, but the x squared minus 11x plus 28 is the PSD method. Because it's x squared x, no number in front of the x squared. PSD, we'll take the number at the end, 28, and we'll come up with our 3 columns. P column, we write all products give us 28. We got 1 times 28, 2 times 14, 3, no, 4 times 7. In the S column, we add them together. 1 plus 28 is 29. 2 plus 14 is 16. 4 plus 7 is 11. Difference column will subtract them, smaller from larger. 28 minus 1 is 27. 14 minus 2 is 12. 7 minus 4 is 3. Now the number we're looking for is a number in our middle term, which is 11, which is right there, so we'll use 4 and 7. So this factors. This is x. We're using 4 and 7, so put 4 and 7 in there. Now our larger number in the P column that we're using, which is a 7, will always be the same sign as the middle term. Well, middle term is negative 11x, so it's negative. The number I circled is in the S column, S for same sign, so if the 7 is negative, the 4 has to be negative. Step 2. Figure out your LCM and multiply everything by it. Let's start with our first factor, the x minus 7. Now we're looking for the greatest number of x minus 7s in a single denominator. There's 1 here, none here, 1 here. So the greatest number of x minus 7s in a single denominator is 1. Then we'll go to our next factor, the x minus 4. And I'm looking for the greatest number of x minus 4s in a single denominator. There's none here, 1 here, 1 here. So the greatest number of x minus 4s in a single denominator is 1. Again, the answer to that question will almost always be 1. So we'll multiply that times our first fraction. And we'll multiply it times our second fraction. And we'll multiply it times our fraction on the right side. Okay. Take my glasses off. They kind of bother me, give me a headache. Let's cancel. So this x minus 7 cancels that x minus 7. This x minus 4 cancels that x minus 4. This x minus 7 cancels that x minus 7. This x minus 4 cancels that x minus 4. Let me write down what I have left, and then I'll take it from there. So I got 3 times x minus 4 plus 2 times x minus 7 equals 9x minus 2. Well, 3 times x is 3x. 3 times negative 4 is negative 12. 2 times x is 2x. And 2 times negative 7 is negative 14. Equals 9x minus 2. And again, no matter where you are in math, you should always combine together like terms, numbers. 3x plus 2x is 5x. Negative 12 and negative 14 gives me negative 26. Okay, step 3. We want to solve for x. This time this is a linear equation. Linear equation because everything's the first power, x the first. We don't have an x squared. Well, linear equations, first step get rid of parentheses, second step get rid of fractions, third step get everything with an x on one side. So I'll take the 9x over to the left side, becomes a negative 9x. I'll take the negative 26 to the right side, and becomes a positive 26. Combine together like terms. 5x minus 9x is negative 4x. Negative 2 plus 26 is 24. And last step is divide both sides by negative 4. And 24 divided by negative 4 gives us negative 6. Maybe. We need to semi-check our answers. And the x equals negative 6. You can actually plug that in at step 1 where you have everything factored. So if I put negative 6 in for the x here, I get negative 6 minus 7, that's not 0. Negative 6 minus 4, that's not 0. Negative 6 minus 4, that's not 0. Negative 6 minus 7, that's not 0. So this one actually checks. That's our answer. Now the values of what caused us problems here is if we'd come up with x equals 4. If I put 4 back up here, 4 minus 4 would give us 0. Or if I come up with x equals 7, 7 minus 7 would give us 0. So again, you need to semi-check it to make sure you don't have an answer that causes a denominator to equal 0. Let's take a look at this one. Problem number 4. 9 over x minus 5 plus 7 over x minus 4 equals x squared plus 22x minus 111 over x squared minus 9x plus 20. Step 1. Factor all our denominators. The x minus 5, the x minus 4 I can't do anything with. But x squared minus 9x plus 20 is a PSD method. Because it's x squared x, no number in front of the x squared. PSD, we take the number at the end, which is the 20, and we come up with our 3 columns. P column, we list all products, give us 20. We got 1 times 20, 2 times 10, 4 times 5. The S column, we add them together. 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9. Difference column, we subtract them, smaller from larger. 20 minus 1 is 19, 10 minus 2 is 8, 5 minus 4 is 1. Number we're looking for is a number in our middle term, which is 9, which is right here, so we're going to use 4 and 5. Everything else remains exactly as is. Okay. So that's x, that's x. We're going to use 4 and 5. Now our larger number that we're using in the P column, which is 5, is always going to be the same sign as the middle term, which was negative 9x, so it's negative. Number I circled in the S column, S for same sign, so if the 5 is negative, the 4 is negative. Step 2. Figure out your LCM. Let's do that first. We'll start with our first factor, the x minus 5. And we're looking for the greatest number of x minus 5s in a single denominator. There's 1 here, none here, 1 here. So the greatest number of x minus 5s in a single denominator is 1. Then go to our next one, the x minus 4. We're looking for the greatest number of x minus 4s in a single denominator. There's none here, there's 1 here, there's 1 here. So the greatest number of x minus 4s in a single denominator is 1. So our LCM is x minus 5, x minus 4. And that's what we'll multiply everything by. So we'll multiply it by 9 over x minus 5. We'll multiply it times 7 over x minus 4. And we'll multiply it times x squared plus 22x minus 111 over x minus 4, x minus 5. Well, let's see what cancels. The x minus 5 there cancels that x minus 5. This x minus 4 cancels that x minus 4. This x minus 5, this x minus 5, this x minus 4, this x minus 4. So let's write down what we have left before we multiply through. So we've got 9 times x minus 4 plus 7 times x minus 5 equals x squared plus 22x minus 111. Well, 9 times x is 9x. 9 times negative 4 is negative 36. 7 times x is 7x. 7 times negative 5 is negative 35. Equals x squared plus 22x minus 111. Combine together like terms. 9x plus 7x is 16x. Negative 36, negative 35 is negative 71. Equals x squared plus 22x minus 111. Now step 3, solve for x. Well, this has an x squared in it, quadratic. So we want to get everything over one side, 0 on the other. And we'd like the number that's in front of our x squared to be positive. So I'm going to take the 16x minus 71 over to the right side. So we got 0 is equal to x squared plus 22x minus 16x minus 111 plus 71. Again, you take anything across your equals, your sign changes. Combine together like terms. 22x minus 16x is plus 6x. Negative 111 plus 71 is negative 40. Yeah, negative 40. Well, now we can factor this using the PSD method. Take our number at the end to 40 and come up with our 3 columns. Write down all products to give us 40. We got 1 times 40, 2 times 20, 4 times 10, 5 times 8. We want to add these. 1 plus 40 is 41. That's the S column. 2 plus 20 is 22. 4 plus 10 is 14. 5 plus 8 is 13. Difference column. Subtract smaller from larger. 40 minus 1 is 39. 20 minus 2 is 18. 10 minus 4 is 6. 8 minus 5 is 3. Now, the number we're looking for is a number in our middle term, which is 6. So we're going to use 4 and 10. Now, our larger number in the P column that we're going to use, which is the 10, is always going to be the same sign as the middle term, which is positive. The number I circled is in the difference column, D for different signs. So if the 10 is positive, then the 4 has to be negative. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 4 equal to 0 and x plus 10 equal to 0. And that gives us x equals 4 and x equals negative 10, maybe. We want to check it. So let me check the x equals 4. Go back up here. 4 minus 5 is negative 1. That's okay. 4 minus 4 here gives us 0 in the denominator. Can't have that. So that one fails. Now if I take negative 10, put it back up here. Negative 10 minus 5, that's not 0. Negative 10 minus 4, that's not 0. And same thing over here. So that problem, or that answer actually works. And let's look at our last problem. So I got 7 over x squared plus 7x plus 10 plus 7 over x squared plus 3x minus 10 equals 14 over x squared minus 4. Well, step 1, factor all our denominators. This is a PSD because it's x squared x, no number in front of our x squared. This one is also a PSD, x squared x, no number in front of our x squared. This one is dots, difference 2 squares. 2 terms and minusing it. Well, both of these are 10, so that works out nice. PSD, we take our number at the end, ignoring signs, and come up with our 3 columns. Write down all products give us 10. We got 1 times 10, 2 times 5. Add them. 1 plus 10 is 11. 2 plus 5 is 7. Subtract them. Difference column. 10 minus 1 is 9. 5 minus 2 gives us 3. Now this first one we're looking for a 7. 7's right here, so we're going to use 2 and 5. 2 and 5. Now our larger number in the p column that we're using, which is the 5, is always going to be the same sign as the middle term, which is positive. Remember our circles in the s column? S for same signs, so if this one's positive, the other one's positive. Now our second one, this one also uses 10. The number in the middle is a 3 though, so we're looking for a 3. Well, 3's in this difference column right here. I'll do it with the square. So we're going to use 2 and 5 again. Our larger number in the p column that we're using, which is the 5, is always going to be the same sign as the middle term, which is positive. The number I put the box around is in the difference column, D for different signs. So if the 5 is positive, then 2 is negative. Now over here, the x squared minus 4. What we try to do with the difference of two squares, try to write it as something squared minus something else squared. We'll start with the x squared. You ask yourself what times itself gives you the x squared, and that's x. And then we'll go to the 4, and you ask yourself what times itself gives you the 4, and that's 2. Now we take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first, and we subtract what's in our last. I swear there's more noise where I live. Trains, sirens. Okay, step 2. Figure out your LCM and then multiply everything by it. We'll start with our first factor, the x plus 2. I'm looking for the greatest number of x plus 2's in a single denominator. There's 1 here, none here, 1 here. So the greatest number of x plus 2's is 1. I go to my next factor, the x plus 5, and I'm looking for the greatest number of x plus 5's in a single denominator. There's 1 here, none here. So the greatest number of x plus 5's in a single denominator is 1. Then I go to my third factor, the x minus 2. And I'm looking for the greatest number of x minus 2's in a single denominator. There's none here, 1 here, 1 here. So it would be 1. So that's our LCM. X plus 2, x plus 5, x minus 2. And that's what we're going to multiply everything by. So we'll multiply times our first fraction. And we'll multiply it times our second fraction. And then we'll multiply it times our fraction on the right side. Okay, let's see what cancels. This x plus 2 cancels that x plus 2. This x plus 5 cancels that x plus 5. Over here, this x minus 2 cancels that x minus 2. And this x plus 5 cancels that x plus 5. And over here, this x plus 2 cancels that x plus 2. And this x minus 2 cancels that x minus 2. So let me write down what I have left before I multiply through. 7 times x minus 2 plus 7 times x plus 2 equals 14 times x plus 5. Well, 7 times x is 7x. 7 times negative 2 is negative 14. 7 times x is 7x. And 7 times positive 2 is positive 14. 14 times x is 14x. 14 times 5 gives us 70. Well, combine together like terms at any step. 7x plus 7x is 14x. Negative 14 plus 14 cancels. Then the right side remains as is. Step 3, solve for x. This is a linear equation. Everything's the first power. So we want to get everything with an x on one side, numbers on the other. So I'll take this 14x over the left side. So we've got 14x minus 14x equals 70. Combine together like terms at any step. 14x minus 14x is 0. And we get 0 is equal to 70. Now notice our x disappeared completely. We were solving for x and just disappeared. Well, the question is, when is 0 equal to 70? And it never is. So this one is a no solution. Now if you'd come up with something that's always true, like 70 is equal to 70, then it'd be an infinite number of solutions. Infinite number of answers. And I think that's the last problem. So let me go ahead and save this video.